So we have a nice simple little lab today based on Charles' law. Charles' law says that the volume occupied by a gas at constant pressure depends on the temperature of the gas. And so we're going to test and see if air follows Charles' law. The first thing that we're going to have to do is assemble our equipment.
This is a basic diagram of what the apparatus we're going to be using should look like. We'll show you in a second what the actual apparatus looks like.
This is what our full experimental setup looks like. On the left, we have our thermocouple for our reading. Next to it is our graduated cylinder inverted in a beaker of water with our connection to it. On the right, we have where the water bath will go and our flask, which is connected by a tube to the graduated cylinder, as well as the thermocouple. And that is what the process is going to do. As we run the experiment, we will be lowering the flask into the water bath at different temperatures, and the thermocouple will record their temperature, and the graduated cylinder will give us their change in volume. Now that we've set up all our equipment, we have to set up our data table of temperature versus the level in the graduated cylinder. You have to keep in mind that the volume in the graduated cylinder isn't the volume of the gas. The gas is actually in the flask, which is over in the water bath. What we're using the graduated cylinder for is to find out what the changes in volume are. So after taking our original volume reading at room temperature, we're first going to cool off the gas, which will cause it to contract, so our first change in volume will be negative. We'll then bring the flask back to room temperature, double check its volume, and then heat it up to 3 different temperatures above room temperature and see what the volume, how much the gas has expanded. We now have to set up our data table. This is what the data table should look like. You'll notice that the first temperature is the ice temperature. We're actually going to start with the second temperature, that's T1, which is the room temperature. We're going to put it in the ice, that's going to cause it to go down in temperature, that'll get us T2. We'll put it in a warm water bath, that'll bring us back up to room temperature, that's T3, and then we have our 3 warm temperatures to work with. Well, there is our initial reading. The flask is at room temperature, 21.7, and the reading on our graduated cylinders, which you have to remember is upside down, is right at the 25 milliliter mark. We can now take our sample, that's our first measurement, and put it into the ice bath and see what happens. And you can see our level is starting to rise. We'll leave it a couple minutes and see what happens. Our sample has now been sitting in the ice bath for 10 minutes. The level is stabilized. We can get the temperature of the ice bath and read the volume on the graduated cylinder. The mark is right there, which happens to be right at the 5 milliliter mark on the graduated cylinder. So that's our second reading, the cold temperature. Now we're going to remove our sample from the ice bath and put it into a flask that contains water at room temperature. Calculate for 10 minutes to see what happens. Our sample has now been sitting in the room temperature water bath for 10 minutes. The temperature of the room temperature water bath you can see on the thermocouple. And we need to take the reading off the graduated cylinder. And the level is right there, which is basically 24 milliliters. And so that's our reading for our second room temperature reading. We're now going to have to move the flask to a warm water bath. So we've heated our water bath to approximately 43 degrees Celsius. Now we'll put our flask into it and see what happens. And so we need to let it sit for 10 minutes. So the sample has been sitting in the 40-degree water for about 10 minutes. We now need to take our reading. The water level is right there, which is 41 on our scale. So that's the volume for the 40-degree temperature. We'll now have to transfer the flask to 55 degrees. So now we've heated the water to approximately 55 degrees Celsius. We need to put the flask into the water bath and see what happens. The flask has now been sitting in the hot water bath for about 10 minutes. It's time to take our next reading. You can see the temperature of the bath. The level of the water in the graduated cylinder is right there, which is 49 on our scale. We now have to transfer the flask to the 70 milliliter water and let it relax. We've now heated our water bath to approximately 70 degrees Celsius, and so we have to put the flask in and see what happens. And we'll have to wait for a couple of minutes to see the result. So our sample has been sitting in the warm water bath for about 10 minutes. Time to take another reading. The water level is right there, which is right at the 60 milliliter mark on our scale. As the last step of the experiment, we need to get the full volume of the flask. We're going to do that easily by just weighing the flask and then filling it to the top with water. And the mass of the water that it takes to fill the flask will give us the volume of the flask, since the density of water is 1 gram per milliliter. Now that we've collected all our data, we can go on to the calculations part. We're going to have to subtract the mass of the flask from the flask and water and multiply by 1 liter over 1,000 grams so that we get the volume of the gas in liters, because of course anytime you're dealing with gas laws, the volume should be in liters. we're then going to have to plot the volumes. And you're going to have to take the volume reading from T1, the room temperature, and subtract it from each of the volumes we have at the other temperatures. And notice that for the ice bath, that's going to give you a negative delta change. You then add those changes to the volume of the gas at T1, and you will find the volume of the gas at all the other temperatures. Once you've done those calculations and formed your graph, we'll then be able to answer the questions at the bottom of the sheet, and the experiment will be done. Have a nice day.